question 8. Right, we've got an object of mass 1.8 moving with 3 on a smooth horizontal surface, collides directly with another object of mass 0.2, which is stationary. So I've got a before diagram. So I've got an object of 1.8 kilograms moving with 3, hitting a mass of 0.2, which is at rest. Then after, the two objects move together, they join together, coalesce. Right? So afterwards I got a combined mass of 2, I suppose, 1.8 and 2, a combined mass of 2 moving with a common speed of v. Okay, so I'm using conservation of momentum, momentum before equals momentum after, and my momentum before is 1.8 times 3 plus 0.2 times nothing equals 2v. So that's 5.4 on the left is 2v. V is 5.4 divided by 2, which is 2.7 meters per second. You've got to be careful that you put all the detail in here, alright? Because you've given the answer, you've got to make sure you're not leaving anything out in your calculations. Okay, the answer is there, otherwise you can lose marks for that. Now then, write down the value of the coefficient of restitution between the objects. Well, the rule for the law of restitution is the separation speed over the approach speed equals E. And then what's happening afterwards is the separation speed. What speed is the front particle moving away from the second particle with? 0. So the separation speed is 0. So E is equal to 0 over 3 is the approach speed. So E must equal 0. Right, that is an example of an inelastic collision. Okay, where the two move on together. Now then, part B, the resistance to motion of the combined object is 8 newtons. And then, so if I just draw a simple force diagram for part B, I've got this combined mass of 2 moving in that direction with an acceleration a, and there's a resistance of 8. So that's the force diagram, simple force diagram. Okay, then apply Newton's second law. Resultant force in the direction of the acceleration is minus 8, and that equals mass times acceleration, 2a. So a is minus 4, so it's decelerating, minus 4 meters per second squared. Read the question, find the magnitude of the deceleration. So I now have to just take the positive value, so the magnitude of the deceleration is 4 meters per second squared. You can't have a negative magnitude. Okay, the minus sign is an indication of the direction. Part 1. Part 2. Calculate the speed of the combined object 0.5 seconds after the collision. So this object now, as it's collided, was moving with a speed of 2.7. Started with that speed of 2.7. It has an acceleration of minus 4, slowing down. And I want to find the speed. I want to find v when t is 0.5. So the equation that links u, a, v and t is v equals u plus at. So v is 2.7 plus minus 4 times 0.5. So V is 2.7, take away 2, so V is 0.7 meters per second. Okay, but obviously part 2, following on from part 1, you needed that acceleration in part 1 to be able to go into part 2. Part 3, determine the distance of the combined object from the point of collision when its speed is 2. So going back again at the start, right, the point of collision, its speed is 2.7, the acceleration is -4, and now I want to find the distance, find s, when its speed is at 2. So when v equals 2. So the equation that links those is v squared is u squared plus 2as. Sub it in, 2 squared is 2.7 squared plus 2 times -4 times s. And then I just got to calculate. So that's 4 equals 7.29 minus 8s. So 8s is 7.29, take away 4. 8s is 3.29. Divide that by 8. And I got 0.411 meters to 3 decimal places.